Good evening, everyone. Today we have with us Mr. Vimal, who is working as a research scientist in Facebook Corporation, USA. To introduce today's speaker, he has completed his BTech in IIT Madras in the specialization of electrical engineering. He has completed his Master of Science in Engineering and Ph.D. at John Hopkins University, Baltimore. He has published 12 research papers specialized in speech processing, machine learning, and natural language processing. He has worked as an intern at Institute of Automation, University of Bremen, Germany. He has worked as an intern at Analog Devices Corporation, USA. He has worked as a research assistant at the Center for Language and Speech Processing at Johns Hopkins University, Baltimore. He has worked as a research intern at Microsoft Research, USA. He has worked as a research, is currently working as a research scientist at Facebook Corporation, USA. So has received Alexa Graduate Fellowship in the year 2018 by Amazon. He is a ECE Graduate Fellowship in the year 2013 and Hamburger Fellowship in the same year by Johns Hopkins University. He has a Weiss Scholarship from DAT, Germany. His All India rank in IIT JEE examination in the year 2000 rank is 191. He is a recipient of KVPY Fellowship in the year 2008 by Government of India and also National Talent Search Scholarship in the year 2007 by Government of India. So we are so happy to have you with us to share your knowledge on the current trend, that is artificial intelligence and machine learning, and definitely its use in the engineering education. We are very happy to have you with us, Vimal, today.
Hi. First of all, thank you to the Department of Computer Science and Electrical and Electronic Engineering from Vidyavadaka College of Engineering for inviting me to this webinar. And also congratulations to the college on attaining the autonomous status. So here in this talk, I'll first go through some introduction to some aspects of speech and language processing. And then I'll take some questions about general machine learning. First, let's start with the classical task of machine learning task, which is an image classification. So this will introduce to the concept of machine learning. So here, the image classification task is given an image. You want to find out what is the object in the image. So it has like a single input x and a single input y. And the input is something like, let's say, for example, an image of a cat. And the output you want to predict the label for that image. Machine learning is just it just involves learning from examples to perform this task. And this process is also called as training a machine learning model. And at the end of this training process, you get a trained model that can perform this task on new data. That is not just the data that it was trained on. And that is how the machine learning model is useful. Popular machine learning model is a neural network model, and it just learns a function that gives a probability of that the label is y for an input x. And this is trained on a large number of training pairs, which consists of both input and output pairs. And for each image type, for each image label, you need many examples to train such a model. On the right, there's an example of an example neural network to predict the label of an image. And there are many output classes, and the neural network's task is to predict the label corresponding to the input object. So far, all the examples I've shown are with a single input and a single output, but a lot of real data is often sequential in nature. So how can we deal with such sequential data? So you can see there are a lot of examples. So for example, there is handwriting written by a person, and suppose a computer wants to find out what is actually written, and this is a handwriting recognition task. And there are also other forms of input like speech or even a video of a person doing something, and these are used by humans to communicate and uh, to show what they're doing. And there's also a language aspect because people speak multiple languages, and it might be necessary to translate across the languages. So all these are examples of sequential data. So how do we deal with sequential input and output? So uh, mathematically, we can write both input and output sequences in the form of a sequence of vectors that can be written as x1 to xt and w1 to wt, w1 to wn. And you can see that the input and output are can have any different lengths. Uh, and So these are of variable length, which means that different examples of like speech or sentences are of different lengths. So they do not have to be of the same length. They can have different durations or different number of words in the sentence and so on. And uh, an example for such a task is a speech recognition task where you have an speech signal as input, and you want to predict what was said in the speech. And this is a speech recognition problem. And the machine translation is also a sequential prediction problem where the input is a sentence in one language, and you want to predict you want to translate it to a different language. And another thing that you can see is that the input and output are also not of the same size. So this means that we cannot apply the previous model where there's only one input and output uh, because we need to account for the differences in the lengths of input and output. Also, it's not possible to directly predict the output sequence directly because there are many possible outputs that can occur, and these are infinite in nature. And for example, in English, there are infinite number of sentences. Uh, so given like a speech signal, you can't predict one of these many sentences. So you have to do something smarter about it. And so the question is, how do you model such a probability distribution of the output for an input? Uh, One standard approach to deal with sequences is called as autoregressive modeling. Here, instead of predicting the entire output sequence all at once, the model predicts it symbol by symbol, one symbol at a time. This follows directly from the chain rule of probability, which can compute the probability of a sequence just as a product of probabilities of individual words given their histories. An example is shown in this animation. This autoregressive modeling is also used for like language modeling, and uh, so if you want to predict a sentence, we don't have to predict it all at once, but predict it one word at a time. So, for example, you can predict the third word, which is cats, from the first two words, which is I like, and then you repeat the process so until you get the entire sentence. And this is the basically the auto regressive modeling. An example model that is used for autoregressive modeling is the recurrent neural networks, and it is one of the most commonly used and simple model for autoregressive modeling. And uh, it it has a set of parameters that define a function and which is applied multiple times at different input time steps. And it also has something called the hidden state, which is computed both from the previous hidden state as well as the uh, current input at a particular time step. And based on both of these, it is possible to predict the output at that time step. And you can see how this can be used for the regressive modeling, because the hidden state has the information not only of the current time step, but also of the previous time steps through the previous hidden state. And so that's how this can be used for autoregressive modeling. Uh, but if you want to, when you have an input and output, um, to convert an input sequence to an output sequence, or to model both input and output sequence, we have to use the recurrent neural network in a special way. And one of these models is the encoder-decoder model, and it is one of the very simple models to output to model sequential inputs and outputs. So it has two recurrent neural networks, and one is called the encoder model, and the other is called the decoder model. The encoder's job is to compress the input sequence into a single vector, which is contained in the hidden state of the encoder neural network. And we can think of this as compressing a signal. And we are compressing all the information, say in like a speech signal. So this is compressing the entire speech signal into a single vector. And the decoder's job is to just uncompress this vector uh, and uncompress the information that is contained in the hidden state into the output sequence. And this model can, in theory, work for any different lengths of both input and output. However, if the sequences are very long, then it is much harder to compress the signal, and you might need more complicated models to actually deal with longer sequences. But still, this is a very good and very simple model. So here is an illustration of how the encoder-decoder model can be used for the task of machine translation. Here, a French sentence is input into the encoder, and the encoder encodes or compresses the information into hidden states one word at a time. And finally, at the end of the encoder, at the end of the input sequence, you get one hidden vector that is passed into the decoder, and the decoder can uncompress this information into a sequence of English words. And you can see that here again, the lengths of the two English and French sequences are not of the same length, but still it is able to handle such differences. So what I described is a very simple model, and obviously there are many shortcomings for such a model. And as I said before, long sequences are much harder to model. And this is a very generic model that does not have any task-specific information added to it. So usually in machine learning, we need to add information about uh, some external prior information about the task or the type of data is very useful to improve the performance of the model. And also, as all neural networks and any machine learning model, this also needs a lot of training data, which consists of input and output sequence pairs. And it's not always very easy to get all this data for different tasks. So there is already a lot of extensions to this model, which are more complicated, complex models like the transformers, attention-based models, and these uh, these are these perform better than the simple encoder-decoder model. And There's also a lot of task-specific knowledge which is added through sometimes you combine with other models um, to use a combination of models, uh, and you can, for example, for like machine translation, you can learn how the information of how the target language sentences are formed is very useful for the task. So it might be possible to pre-train some part of the neural network or add some biasing to the neural network to make the prediction better. And there's also a lot of research to try to use less of labeled supervised data because these are very hard to get. So we want to just use unlabeled data, which means it's not anymore like paired data with both input and output uh, pairs in the example, but you only have examples of one of the sides, so either input or the output. And learning from these is a research direction. And there is a lot of currently it might be possible to access a lot of data because there's a lot of data being produced, like a lot of speech data and a lot of text data from the internet and so on. So these are very useful to um, uh, train better models. And recently there's also a lot of uh, 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 research on like multilingual uh, usage of the data. Uh, there's not even though a lot of research has been done on like a single language or English or some of the European languages, but there are many languages where there is not enough data to train on, and these are called low resource languages, and there is a lot of interest in these areas right now. So lastly, I want to talk about some of the challenges to apply these uh, speech and language technologies in the Indian context. So India is unique in the world in terms of diversity in language and culture, and uh, and so on. And there are like 22 official languages in India, and like thousands of languages and dialects, and many more dialects. And many of the languages are only spoken, and they don't even have a written form, or maybe the written form is not in use. Uh, and there's also a lot of usage of spoken or colloquial form, and these are different from the standard written forms. And you can observe this in many languages. And these make it much harder because it is not possible to collect all this kind of variety of data to train a machine learning model. Uh, in the Indian context, it's also very common for people to speak multiple languages, and it is people might also switch between languages very easily. So, like it's possible to use like English words in when speaking a Kannada sentence, uh, and the native language of a person also influences the accent of the person. So the accented speech itself is a very uh, hard task, and general speech recognition systems may not be able to deal with the accented speech directly. So there are research work in this direction to make the model more robust to such kind of speech. Uh, Also, there's a problem that the literacy rate is pretty low in some of the areas, especially the rural areas. Uh, so, so text-based applications may not have much of a use here, but uh, the speech-based interfaces become more important because the speech is a main form of communication with by all these people. And uh, for example, in IIT, there was a project to enable farmers to ask for market prices through speech recognition. So this is an example where the speech recognition helps to enable reaching more people, especially in such rural areas. Um, and there's also people from different areas speak different languages. So machine translation might be very useful to increase the reach of information to all these peoples. So this is the end of my talk, but I'll be happy to take any questions that you have.
Yeah. Okay. It was a nice presentation. Like what you gave was some sort of introduction to the entire speech processing thing. So we have a couple of questions what we can take now. And yes. So the first one what we have here is, can we develop a artificial intelligence using the data from history to predict occurrence of the pandemic and natural disasters?
Yeah. Um, so as I mentioned, machine learning models are pretty useful when there's a lot of training examples, um, and but in cases where such pandemic and natural disasters and so on, there's still maybe not enough data that you can get from history. So there's a lot of work by just scientists to just analyze the data and find out why some of these uh, are happening. Uh, and machine learning models can maybe help to find out some patterns in the data, uh, but it may not be very obvious to just to directly use it to uh, uh, predict something. And this is still in the job of scientists, because uh, they need to understand what inputs and what signals to take in to make such predictions, and also uh, yeah, there's still a lot of need to understand why of uh, these things happening, and uh, machine learning models. Some it might help to augment what they're doing, and but it may not be right now. It may not be able to directly predict these unless there is like you already have information about what signals to take as input and so on.
Yeah. So that was and the next question is, AI and machine learning has its own drawbacks, as every field has it is, and any specific suggestions to overcome it?
Yeah, so I already talked about some of the shortcomings with some of the machine learning models, and this is the fact that there is not enough data in many of the tasks, and uh, you do have data in some of the large domains, but in when you go to like smaller domains, or uh, like things like Indian languages, or like other uh, different dialects and so on. So there's very little data that you can collect in all these many different diverse sources. And as you go to reach many more people, there's also a lot more devices and a lot more environment changes and cultural changes. And these make modeling uh, the speech and language much harder. And these are some of the challenges that you see.
Yeah. So the next question goes this way: where to start machine learning? What are the basics to have it in learning, machine learning and AI? So how a career can be pursued in AI? So if they are not from a CS background.
So to start with machine learning, you might need some. The main things are some basics in in maths, and uh, like you need to know things like linear algebra, probability, statistics, and these uh, are the foundations for starting to learn about machine learning. And obviously, you also need some knowledge about coding uh, in some language, because you might need to implement these algorithms. But to understand the algorithm, it's mostly a lot of mathematics and statistics. And
Okay.
you can learn. Uh, there are Obviously there are many courses Nowadays, there are many online courses like Andrew Ng's course, which is a great introduction to machine learning. And there are also there are also many resources available online. Um, like one of the easiest way to follow like recent developments or papers is through like reading some blogs about the paper. There are many blogs, articles that talk about some machine learning works and summarize the papers and so on. So it might be easy to get into those through that. And there are also books by many authors. Um, I think there's like pattern recognition, um, and uh, uh, there's by I think Christopher Bishop is the author for that, and there's natural language processing I think by Christopher Manning, and there's like a deep learning book by Ian Goodfellow, and these are some of the sources that you can look at.
Okay. So, how is the job opportunity in the area of artificial intelligence and machine learning for a fresher? So, any insights about the job description after having a degree in AI and ML? So, how are the job opportunities there?
So I feel like for uh, machine learning, you need to first have a lot of basics about, as I said, about mathematics, statistics, probability, and so on. So, and you need to get a lot of these basics at the undergrad level, and uh, at the machine learning itself, I think there's uh, uh, maybe there's a lot more a very specific study that needs to be done here, and probably there's like a master's uh, or more advanced level courses are needed for getting into really getting into ML. But it's still possible to uh, use some of the knowledge about coding or implementation to get into uh, get into the ML at a more fresher level. And right now, I think ML and AI are being used in many different fields. So, and as always, there's always like a task-specific information that is always very useful for machine learning, and you always need some kind of expert knowledge to actually improve the model. Like you need to know what features to use and so on. So these are ways where anyone from any field would probably be able to get into ML.
Okay, then. Which language is good for coding in machine learning and AI? So, how is it useful? So, whatever the platforms that you take, so which is the best programming language that you would like to suggest for a learner or a fresher in learning machine learning and AI?
Yeah, so right now, I think Python is the most popular language uh, for for machine learning, and there are a lot of like tools like uh, PyTorch, TensorFlow, and so on. And a lot of these are also internally using like C++ or some other languages to make it faster. So you might need to start with even like C or C++, which are also important. But to just get into the maybe just the basics, at least Python is required.
Yes. So, as you highlighted in your presentation, so any future areas in which proper research can be carried out. So, an interdisciplinary project or research in the area where you can integrate your machine learning aspect and artificial intelligence techniques, a few of them, in the electrical engineering domain or in civil engineering or certainly in mechanical engineering. So, where we can generally have such things being there.
Mm, yeah, so I'm not aware entirely of how it works in like different areas, uh, but some of the main problems like the access to quality data for training and so on. This is like a common problem in from any different fields. So trying to get models to work with smaller amount of data is probably an important direction. And a lot of uh, some of the fields might have like specific kind of data. Uh, like for example, like even the thing that I talked about natural language processing required like sequential data, and in some other domains it might be possible that the data has a more structured data like graphs, and it might be possible to add some more domain specific knowledge into the models to improve the performance. So uh, like the neural network architecture and so on can be designed to be specifically tackling some particular problem. And these are areas where there could be uh, like research.
Yeah. So that is one thing that is there, and the next one is how artificial intelligence and machine learning technologies can be made to be available in the rural masses, generally who own smartphones these days, and how it can be used to the rural areas, generally where internet facility is a major concern there.
The the internet and the other technology access in the rural areas is definitely a problem. But right now, I think a lot of like these things are getting better because of cheaper internet and uh, better distribution of power and so on. And uh, so I think it is uh, it is definitely a hard problem to reach all these masses through that. But there is also a lot of potential because uh, the things like language technologies will be very useful for reaching all these rural areas because of there's like a barrier of communication uh, because of the different languages people speak, and because of the lack of uh, uh, like like a good literacy rate and so on. It is so there's a lot of potential for uh, these technologies to help in those areas, and and yeah, and most of the like speech technologies and so on, they all run on like a usually current models. They all run in like a server mode. All of these run. They don't need to run on like the smartphones themselves, but there is also a lot of research in that direction where you can make the models work in like smaller devices as well. But there's still a lot of research to be done in this direction uh, to work for speech recognition on like embedded devices and so on. And there is still research that needs to be done here.
Yeah. So, specific question from my side. So, how like the education now you can see computer science engineering and information science engineering, and this new branch AI and machine learning. So, how it has an impact on the job market or something like that. So, how it is generally being used healthcare sector, defense, and any area that you name, you are having artificial intelligence and machine learning generally coming up. So, how the education background? So, how you can generally use it with respect to the education background? Those are my questions.
Um, yeah, so right, I think in the past there was not much focus on uh, like collecting data uh, for any particular like these machine learning tasks. So now, as machine learning has become more popular, there is you can see that having data in many different domains is becoming has been useful, and um, and there's a lot more interest in like collecting and retaining data and to analyze what is in the data uh, and to see how that helps to train new models. And so I think in that way, uh, things are changing because there's just more access to data, and it might be possible to use ML to help in these scenarios.
Yeah. Okay then. So one last question from one of our viewers. So how to read a bad handwriting?
Um, yeah, actually, handwriting recognition is a much simpler problem than a lot of like speech recognition and so on. And because there's a lot of noise in speech, and there's a lot of noisy settings. Like there might be like a restaurant or in trains, and it is possible to still do speech recognition in some way, even there. So handwriting is a simpler problem, maybe compared to that. But there has been a lot of research in this direction, and as I already mentioned, there are like sequential based models, but usually there are more complicated models than what the model that I described. So you need to have a lot of prior information about how the sentences are. So if you know uh, so this is where like the prior information, like a language model, comes in. So if you know how English sentences are formed, so you have that idea, and you based on that, you can decently predict some of the words, even if the handwriting is bad. Uh, so you might be able to predict some of the letters or some of the words, and based on the knowledge of how words are formed in English and how the letters form words, it might be possible to predict or close the gaps that you cannot understand from the handwriting.
Yeah. So yeah, those were some few questions related to artificial intelligence and machine learning. Uh, yeah. So just a moment, madam. Hello,
Yes, Anup.
madam. Yeah, yes, madam. Any
Yeah,
questions from?
no, I don't have any questions because we have seen how artificial intelligence and machine learning can be incorporated in whichever domain or area you want, whether it is electrical power engineering or electronics or any other field for that matter. So nowadays we can see that because of huge data, so we are able to make use of the machine, and we will ensure that whatever job human beings were able to do, the same job can be done by a machine. So it has a very wide opportunity almost in all the domains, whichever domain you take for that matter.
Yeah.
So thank you very much, Vimal. So you've highlighted about the starting from the fundamentals and taking up to the application level. It was really very good.
Okay. Yeah. Thank you. Yes.
Yeah, thank you, madam. Now we have come to the end of the webinar. I would really like to thank our HOD madam, Dr. Shobha Shankar, for giving me
Thank
this opportunity to uh, conduct this webinar, and also the entire faculty of our department, electrical department. And I would like to thank the management and also our principal for giving me an opportunity to have this webinar. And thank you, Vimal, for being online and delivering from the fundamentals to the application level of this webinar on artificial intelligence and machine learning.
All right. Thank you, everyone, once again for joining. And it was great to be here and present my ideas and application ideas.
Yeah.
Thank
Okay.
you.
Okay. Thank you, Vimal. Thank you.
Okay.